So before we get going, I'm going to introduce myself briefly. My name is Helen Leigh, and I am a hardware hacker. I like tinkering with lots of different things, but I primarily make experimental musical instruments out of interesting electronics and all sorts of other things as well. You can find me on Twitter. I'm Helen Leigh, that's Leigh, where I post a lot of my projects. And I also have a slightly shoddy GitHub, which has got lots of interesting things in it. I do try and document all my projects, so I put them up there. And today, I'm going to be taking you through my electronics toolbox. So I really love hardware, and by hardware I mean all the physical bits that make up computing. And I'm a big fan of the electronics too. So today I'm going to take you through my electronics toolbox. I'm going to show you the basic tools that you'll need in order to be able to make electronics work for you and your projects. I'm also going to be showing you how to use some of those tools. I'll be taking you through lots of different bits and pieces that you might want to become accustomed to as you start your journey with electronics. So let's get started. I'm going to be pointing this camera down at my workbench so we can have a look at some things. And I'm going to show you a bunch of how to use all the tools. So here we have. Let's move this down a little bit. I'm using a hacked IKEA lamp with a webcam that has been extremely stylishly cable tied on. So hopefully it won't fall apart. Oh, look at that. It actually doesn't look so bad, does it? All right, so here we are, hands. Let's start off with some of my basic tools. So the most basic thing you're going to need to use if you're doing anything with electronics is one of these. This is my baby soldering iron. It's not an expensive one, but it is quite a good one, and I'll show you why. So here's the business end. This is the bit of the soldering iron that I do mine. It's not turned on at the moment. I will turn it on and show you how to use it in a bit. But this is my cute little soldering iron. It cost me 15 euros, so it doesn't have to be crazy expensive. But what you are looking for is that you want one that has a temperature control, okay? And you want one that's comfortable in your hand. So I went actually into a physical store and I picked up lots of different soldering irons, and I found the one which I felt more comfortable holding. Some people prefer a weightier soldering iron, and some people prefer one that's a little smaller. I prefer one that's a little smaller because I do a lot of fine work. But the downside with this particular one, and one that you might want to watch out for when you buy your own soldering iron, is it's got a pretty low wattage. So this is 10 watts max. That basically means how much power it can, how much grunt it's got, okay? So this is totally fine for soldering most small pieces, but it will struggle with anything larger. For example, if you wanted to solder on like a USB port, it couldn't do that. This is only good for fine work. I do have a second soldering iron with me, which has, I think this is an 18 watt one. And the reason why this one's kind of cool, so this is a slightly pricier one, and it's called a TS80. This is kind of an iconic one because it's got a USB. I don't know if the focus will focus onto it. Yeah, here we are. Wobbly hands. So this is a hey, sorry. So the stream's going to be about an hour long, give or take. Okay. Let's see how much we get through. Right, cool. So this is a lovely soldering iron. The reason this is cool is because it doesn't go into the wall. This one actually plugs in using USB-C to a battery pack. So this is a great little soldering iron. That is very, very portable. And again, this is temperature controllable as well. I'm not going to plug this one in, but you can see it's got little buttons here to turn it up and down. So temperature controllable. When you're looking to buy your first soldering iron, you should always get one that's temperature controllable and one that feels comfortable in your hands. Now, again, you'll see that I quite like these smaller ones that are a little bit more deft. So those are my two soldering irons that I keep. This is my little workhorse that lives on my workstation, and this is a traveling one, which is actually slightly better because it's got more wattage. It's a little bit more powerful. Thing to do anything with electronics, you probably need a soldering iron once you start making your own things. I'll come back to the soldering iron later, and I'll show you how to use it. But I want to show you some of the things that go with the soldering iron. You don't have to. I'm going to tell you a lot about different tools in the first part of this stream, but don't worry if you don't understand everything. All I wanted you to do is to become familiar, really, with the tools that you might see on an electronics workbench. Even if you don't know how to use all of them by the end of this hour, at least you'll know what they are and what they do. So, the most important thing when you're using a soldering iron is you've got to keep it clean, okay? And I will go over that when we actually start soldering later in this hour. But this is essentially like a little steel wool brush. I'm not actually sure if it is real steel, but probably, I don't know. Anyway, so what this is a cleaner. So if you've seen a soldering iron before, you might have seen a little sponge, or you might have seen a scrubby brush. Now, I much prefer using one of these scrubby brush things. Firstly, I feel like they are way better. And secondly, it's just more fun because you just have to stab it in there. So in between each solder, and again, I'll show you this when we start soldering, is you just have to stab it in there, and it cleans the tip. Because a clean tip means you're going to have a much nicer solder joint. So, yeah, so here, soldering joint. A thing to clean it with, either a sponge or a stabby brush. The next three most common things are this. This is my type that I like to use, something called helping hands. Now, the more common thing that you'll see is a metal one, which might have two little crab hands and possibly even a magnifying glass. Now, I use this type. This is actually a gift from Konichiko Akiti on Twitter. But I really like this because I often solder kind of unusual shaped things that might be twisty or turny or even made of fabric. So I like to use this one, which has got nice articulated arms. You can also get the creme de la creme is like a magnetic base one with several of these twisty arms, but I don't have one of those, which is very sad. But yeah, so one thing to look out for with helping hands, again, it's a matter of preference in terms of which ones you get, whether you get the metal crabby ones or if you get these ones, or you can actually, in America, and I've been visiting hackerspaces in the USA, I've seen longer limbed metal crabby arms, which I don't particularly like, but they are common. But anything that's kind of articulated and has these grabby hands, which keep your project stable while you are soldering on it. One thing you should watch out for is, if you can see here, you'll see that these little metal grabby hands, they've got plastic over them. Now, that is to protect your board, your electronics, while you solder it. That's very important. A lot of the cheaper pure metal grabby hands don't have those, but you can fake this with a little bit of shrink wrap, or I've even used little bits of plastic before, just because I don't want the bare metal teeth to be scratching my projects while I'm soldering them up. So yeah, make sure that whichever helping hands that you've got, make sure they've got a nice cover, either real or improvised, over the top of them. So there we are. The next two tools that I'm going to show you, completing the set of 5 essentials, I would say. Here we go. Are these two. So this is something called a flush cutter or a diagonal cutter. It's essentially just a little, also often they're called snippers as well. Essentially, they snip things, which is why we call them snippers. What they do is, oftentimes when you're looking at a component like this, you might solder it through something, and then it'll have these long leads that are left over. So basically all they do is, they're called flush cutters because they, hang on, put this way around. If you want them to, once you've soldered them, these have got a nice flat edge on this edge so that you can hold it close to the board, close to your project, and snip it off using diagonal, these little diagonal things. So I'll demonstrate these and use later. But these ones are also essentially snippers, but different. These are wire cutters and wire trimmers. So there are a couple of different styles of this particular tool. I prefer this kind of manual tool. But you'll notice here, it's mirrored, it's kind of confusing, that you have different values next to these little holes where next to the blade. And essentially, these are ways of exposing the wire's innards. Okay, so if you take a look at this, this is some standard wire. You'll notice that you've got this plastic coating, and then you've got a metal bit in the middle. Okay, all these are for doing is for exposing the metal bit in the middle. So basically snipping off the plastic bit without snipping off the metal bit, which allows you then to solder or attach the rest of the wire. Blimey. Okay, so let me just show you how to use these while I've got them in my hand. So these have got a lock on them. So obviously you're going to open up that lock like this. Here we go. So now we've got this spring, which is allowing us to do that. Now I'm going to go up in here. So basically, here we are. This is 16 or 1.3. So AWG here is the American wire gauge, and that's just the thickness of the wire. Now you may have noticed from my accent that I am not American, so I like to use imperial. So it's got a millimeter measurements on the other side. Now you'll see here, this is quite thin wire, electrical wire. You'll see that this is not suitable for number 16. What about 18? Again, it's too thick. If I went all the way down to 26, the hole is so small that it's going to cut all the way through the wire as well. So basically, I need to find out which wire hole works for the wire that I'm using. Now let's do it here. Basically, all I've done here is I've gripped the wire in my wire strippers, and then I'm going to take the other side of the wire in my left hand, and then using my right hand, I'm just going to work it off. See that? So that has left. There's the little bit of plastic left over. So this essentially hugged the actual wire and cut through the plastic, and then by pushing away, I'm able to remove the plastic coating, leaving just the bare wire, which is much more useful to us. Yeah. Now, you also have this blade down the bottom here, which is for cutting the wire. So I now have my piece of wire, which has been stripped. I'm very happy about that. What I want to do now is essentially just boop. I now have a strip to this end, not a strip to this end. This is a useless piece of wire, but imagine it was going into something, and it would be useful. So that's how to use a pair of wire strippers. Let's put that back again. You'll also notice here we've got a warning: wear safety goggles. And when you've got a wire in your hand, it's not so bad, because if you notice, like I was holding both ends, right, when I cut it. So it's not flinging anywhere. However, if I was using these to cut wire like this is kind of on a resistor, do the YouTube beauty technique of showing on my hands. This is like small and sharp, and it doesn't weigh very much. So when I snip it, it's going to get pinged across the room, which is bad, right? Because we don't want it to get pinged into our eyes or into anybody else's eyes. So you can wear safety goggles in your lab, but you can also just be really mindful that when you're snipping something, you should hold the end that's being snipped so it doesn't fly off somewhere and hurt somebody. Okay, so there we are. That's wire strippers. So we've had a brief introduction to the five essentials. So wire strippers, snippers, helping hands. Let's push that this way. We've got the soldering iron cleaner and the soldering iron itself. Those are the 5 most essential tools that I would use for everything. The next the next portion, I'm just going to show you some of the other tools that I use, but these are the most important things. These are the ones you'll start using straight away, okay? So yes, there we are. We'll come back to those when we actually start soldering in a minute as well. So most important things. So next up, we have a couple of my other favorite tools to work with on an electrical bench. So we have this. This is once you start soldering something, eventually you're going to make a mistake, which is fine, and you're going to need to desolder it. In order to do that, you're going to want one of these. This is called a solder sucker, and this particular brand is everyone's favorite because it's way better than like when I bought. It's called Engineer. It's a Japanese solder sucker tool, and they sell it I think at Adafruit and in P. for in the UK. I think mine costs like $20 or something. Anyway, it's amazing. It changed my life. Would definitely recommend this solder sucker. And the reason why it's so good, apart from the fact it's got a great suction, is because it's got this lovely silicone tip here, which means that you can hold it against the solder and really get it out of all the nooks and crannies. I will show you how to desolder later. It's a little bit more advanced than soldering, but it's a useful skill to have. It just takes a little bit of practice desoldering. Yeah, this is my solder sucker, which I love very much. Another thing that I find really important when I'm doing soldering, particularly on slightly smaller soldering, these things. Here we are. So this for smaller soldering, for example, if you're using little chips or something, I will use these. So here we have. This is one of my set of electronics tweezers. They are extremely sharp, extremely fine, and they hurt a lot if they go underneath your nails, which I did only yesterday because I never learn. But yeah, these are for picking up and placing down very small components. So tweezers are an essential. I have a set of maybe 20 different sizes of tweezers on my electronics workbench. So yeah, these tweezers are the bomb. The other thing that you'll see on an electronics workbench is something like this. So this is two different form factors for similar kinds of things, and this is called flux. Now, flux is like a magic liquid. It's basically the lube of solder. So, oh my bad, I didn't introduce you to solder. It's solder itself, but maybe solder and flux can come in the same little section. So here we have solder and flux. So I showed you the soldering iron, but the actual material that we have to use with a soldering iron is this stuff. It's called solder, okay? And this is two different, you get, just like a wire, you'll get it in different widths, and you'll also get a couple of different makeups, right? And everybody's got their own preferred brand. But there's two major differences between types of solder. We have got leaded and unleaded, or lead-free solder. Leaded solder is easier to work with. I won't tell a lie. However, it's also a bit poisonous. And as a result, it's best practice to use lead-free solder. A best practice that I happily ignored until earlier this year when I left my last role of leaded solder in the UK, came back to Germany, went to the hardware store, and they told me that it's illegal to sell it in a generic hardware store here, which I was very upset to hear. So I have made the switch to lead-free solder. It is a little bit more difficult, and you do need a little bit of something called flux. So this is flux. Flux essentially helps your solder go where it's supposed to go, okay? It's like, it just helps it flow, okay? And you'll see that that it really helps, particularly with lead-free solder. Now, I will give you a little safety tip. If you are using leaded solder, if you have leaded solder, if you find it easier to work with, lead is poisonous, very poisonous. And if you are soldering with leaded solder, you must always, always, always wash your hands, because once that lead system, it literally can never leave, okay? So poisoning is serious. It accumulates on the brain. So if you do use lead solder, be aware that you must practice good hygiene afterwards. Don't be sitting there soldering with leaded solder and eating Cheetos at the same time, or you'll go a bit mad when you're older. Nobody wants that. So this is the two different sizes of solder that I have. Oh, one more solder tip is if you go into a traditional hardware store, I'm talking, you know, like saws and drills and so on, you might find a third type of solder called plumber's solder. Never use plumber's solder. In the middle of plumber's solder is a kind of acid, and it will eat your electronics alive, and nobody will be happy, okay? So plumbers, never use it. Leaded, nicer to use, but poisonous. Lead-free, a bit more fiddly, but if you use flux, everyone's happy, okay? And you also might find that thinner solder is much easier to work with than thick solder, okay? So, yes, this is my current lead-free solder, and it also has flux inside of it, which is great. But often when I'm doing small bits of soldering, I will use a flux, extra flux, to make everything flow a lot easier. So this is just a brand. Chipquik is a brand of flux. This is a nice, easy way. So this is like a pen, essentially like a Sharpie, but out of the bottom of it comes this clear liquid, which you just paint onto your boards. Again, I will show you that in action once I actually start soldering. But yeah, basically, and you can also see it often in this kind of thing, which is this is a syringe. So you can like you can squeeze it onto your boards as you work. There's lots of different types of flux. As you start out, you don't have to worry too much about that. There is a really great Hackaday article on the different types of flux. And indeed, there was a good Hackaday article on the different types of lead-free solder as well. So I would just encourage you to play around and see. And you know, sometimes it's the solder that doesn't work, not you. So if you're having a really hard time soldering something, do consider switching out your solder to something a little thinner, or maybe using some flux, okay? So yes, that's solder and flux. We're also going to show you this. Oh, this is a multimeter. It looks a bit scary. I was a bit scared of it the first time I saw one, but this is your debugging tool. Now, if any of you are software developers or play around in software, you'll know that debugging is the process of finding out why things don't work, okay? Now, a multimeter is the physical alternative, it's like the equivalent, okay? So it's a way of figuring out why your circuit's not working, okay? It can tell you how much power is still left in your battery. It can tell you how much electricity is flowing around your flowing around your circuit at different points. But when you're starting out, the most useful thing for debugging your circuits always looks a little bit like, let's move this out here, because see if we can get it focused. Yes, we can. All right, you see this little one here, it's got a little dot that goes out. It looks like it's like an audio thing, okay? So essentially what that does is it can tell, it's a continuity tester, which essentially tells you if there is a circuit, like a path between one point and another, an electrically conductive path. All right, so I'm going to select this. All right, so I've selected the connector. So essentially, it doesn't, to use this, it doesn't matter which way round it is. You don't have to worry which one's red, which one's black. All we're checking for with this one, the most important part of a multimeter when you're starting out is whether there is an electrical connection or not. So essentially, when I touch the two probes together, it'll beep. Yeah, we can all hear this. Notebook 123 just asked if multimeters are expensive. No, they are not that expensive. I think you can get a decent multimeter for around $20. Have a little look on Adafruit's website. They're not so expensive. But what you can do then is you can test if something's conductive, or you can test if two parts of something are electrically connected. So let's touch here. Oh, look, the table, astonishing, literally nobody is not electrically connected. But if we get something that's metal, let's say, here we are, the bit of my little portable soldering iron. So from here, whoop, it's rolling around. I should have chosen something that's not rolly. Let's use not quite so rolly. Let's use a resistor. I'm going to touch here to here. All right, so yes, that is electrically connected. If we touch here to here, there's enough resistor to be enough resistance. I don't know what value resistor this is. Yeah, okay, so there is no direct electrical connection, so it's not beeping. All right, so basically, a multimeter is a wonderful tool when you're starting out. I don't want to go too much into the technicalities of a multimeter because it kind of gets a little bit overwhelming, but I would say when you're starting off, just remember that this is your debugging device, and this little symbol here that's got it's a dot going out into waves, it's a sound. Basically, you can tell if something's connected or not. So if something's connected and it shouldn't be, or if something's not connected and it should be, this device can help you figure it out. This device has saved my bacon many, many times. So, talking of connected or not connected, sometimes this is my also very useful thing to have on the desk. This costs like $1 or something. This is electrical tape. You'll see this in lots of different colors. It doesn't mean anything. That's just for your own reference, and that goes the same for wires as well. It doesn't matter. So here's 3 wires: a black wire, a red wire, and a yellow wire. And they make no difference. They're just for you, the human, to know what's connected to where. If everything's connected in one color, it can look like a spaghetti mess. So these different colors are just to help you. They don't actually mean anything. Same with this kind of this electrical tape. Electrical tape is just an insulator, okay? It's the type of tape that electricity can't get through. So you can use it to wind up the ends of your wires if you don't want them touching other wires and making a mess of your circuit. So there we are. All right, so I have shown you this basic equipment for my electronic workbench. I did want to have just a minute to tell you a little bit about different types of wires. Now, a wire is a wire, right? You can put electricity through it. Doesn't really do anything different. But that's not strictly true. There's lots of different types of wires, and it's actually very helpful when you're starting out to know what the different types are, the basic different types of wires are, because it's going to really help you build your project in a way that they're not going to break in about 10 seconds. So I'm going to show you some of my some different types of wires, and then we're going to do a soldering project together. Okay, so here we have these. I've shown you before. These are from Adafruit. These are 3 different types of colors of wires. We've got black, we've got red, and we've got yellow. Again, it doesn't mean anything unless you want it to mean something. There are traditions. So for example, black in small scale electronics will typically be used for ground. Red will typically be used for power, and yellow will often be used for data. But if you are working on something in your own home, and it doesn't really matter, okay? The wire does the same thing. It's just convention and it's just convenience, okay? So let's have a look inside one of these things. Right. So here we are, I've got my wire strippers out again. And again, I am going to clamp it on here and pull off. So I have exposed the wire underneath on this black wire. That's very exciting, isn't it? Okay, so what we have here is a type of wire called solid core wire, and that's because this wire has a solid core. It's made of one piece of wire, okay? One piece of wire. Oh, and David Gloat has said color has meaning such as black for ground and red for power. Color does have meaning, but the actual wire itself does not. Okay, so it's not different. Okay, if you are in a pinch, you can use black for power. It's not going to make a difference. It might make it slightly more confusing, but it's just convention. Okay. So that's something called a solid core wire. I'm going to show you the other type of wire here. Let's see if this is very thin wire. Here we go. So inside here, we have the other major type of wire. This is called braided wire. And you'll see, hopefully, if I can make it zoom in to move all the other things out of shot. So hopefully it'll focus. Let's see. Here we have. Here we go. Okay, so it's managed to focus. You can see that this braided wire is made up of lots and lots of different tiny wires, okay? Whereas this wire, the solid core wire, is made up of one single fat wire, okay? Let's see if I can actually focus this. Well, I can't really seem to focus it, so you're just going to have to take my word for it. We've got solid core, which is this one, is fat, and a single core, and then braided, which is this one, which has got lots and lots of smaller wires, okay? They have different properties, okay? So the fatter the wire is, the more it can carry, okay, right? Just like a pipe. So think of a wire as a pipe for electricity, okay? If like a water pipe that has lots of capacity can take a lot of water, and the same with electrical wire, okay? So the fatter the wire, the more electricity it can take. But for most electronics projects, you'll find with something small like this. There's quite a big difference between solid core wire and braided wire. Let's just illustrate this here. Okay, this is solid core. Look what it does. It stays in shape. Whereas braided, no, you can't make braided stay in shape. Braided is very loosey-goosey, okay? It moves around, it's much more flexible, it doesn't stay in shape. This kind of solid core wire, if you move it around a lot, it will become brittle and snap. So if your application for your wire is something like a wearable, if you've got it on your body, you're going to want to choose a braided wire because it's flexible. If you use something solid core on something that moves around, it's going to snap. Solid core is much better for something that just stays in place inside of a box, okay? So yeah, anything wearable, anything that moves, use braided wire. Anything that's a bit more permanent, you're fine with solid core, okay, that stays in place. Okay, those are the two major types. There's also, I'm going to show you, just grab these from my over here. Here are a couple of other things that you might come across pretty commonly. Let's move this here. This is a type of wire that's often used, both of these types of wires, let's move these wires out of the way, and we've got a set of wires that are used a lot for prototyping, so when you don't know that you've got something finished yet, something that can be easily done and undone, okay? These are called jumper cables. There's different types of jumper cables here. There's little round ones, there's little square ones, but essentially jumper cables are things that you can pull in and out of things without having to solder them, okay? And I'll show you a breadboard in a bit as well. But yeah, so those are prototype wires, and you get different types. This is 2 pins, also called males, but you can also get ones with sockets, also called female. Let's see if I can find some of those. No, I don't have any on my desk. Well, so you've got little socket ones, or you've got ones that go from pin to socket, or male to female. There's different types of ones for different applications. You also have these. These are called crocodile clips, or in America, They're called alligator clips. You can see, look, they are like little tiny alligators. Nom, 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 nom. Let me just pull the cover off and you can have a look at what's inside them. So essentially, it's just a small metal clamp. And what that does is it allows you to just clamp onto something quickly, let go, and then prototype it. Now, of course, this isn't going to be useful for something that's in a project long term, but for just like whacking something on there to give it a go, these are great. They're great for prototyping. Again, yeah, jumper cables, alligator clips, and then one of these things, which is called a probe. Okay, so you pop with these are a bit more advanced, but these are great for small sensors. And this is I bought this from Adafruit actually. Again, so what you do with this is you pop in, for example, this is a pin-to-pin jumper cable, jumper lead, they're also called. And I would pop that into a microcontroller, for example. And then, so that's gone into the black one here. So at this end, yes, crocodile clips. You'll see that it's got a little, let's see if I can make that focus. Here we are, look, okay, so this is like a little probe, okay? So essentially what you do is you can hook on to something else. Like say, for example, this is a little circuit board. So hook that on here, and you can hook it on without making a permanent connection, okay? So this might be useful when you're prototyping with little sensors, okay? This is a little probe clip. You've got the ones that are little hooks, and I think on this one you've also got ones that are not little hooks. Yes, here we are. So you've got little grabby things as well, look at that. Let's see if I can focus on it. There we are, look at that. Yeah. Nom, nom, nom. There we go. So you can actually grab onto things as well. Okay, so yeah, these are really worth knowing about. And again, these are fairly inexpensive. They're less than $10 for a set, and they're just helpful to have around for prototyping. So yes. Oh, David says, I'm missing the fan recommendation or air pump with a filter. Otherwise, lungs are a very good filter, but you want to avoid that. That is a very good point, David. So when you're soldering a lot, which we'll see in a minute, I'm about to turn on my soldering iron, you will get a little bit of fumes from the flux or from the leaded solder. You'll get a little bit of fumes. So what you want to do is, I've got a very good air circulation in my apartment. So I just normally open the window and maybe use a little fan. You just want to be able to blow that away. You can also get specialized fans with little filters, like carbon filters, which are good as well. But I don't have one here to show you, in fact, today. But yes, that's a good point, David. So those are my little prototyping wires. And then when it gets to permanent, those are the two types of wires I'd use. So either solid core for something more permanent, or a nice flexible braided wire. Lovely stuff. Okay, there we go. That is a tour of my basic toolbox. Oh, there's one more thing that I didn't show you, is my lovely set of calipers. Calipers are essentially, they're just a ruler, but for measuring very precise measurements, okay? So I have one of those on my desk as well. But yeah, that's my basic set of equipment. I'll just take you through. Would have on my day-to-day thing. Oh, another thing I want to show you that I don't use anymore, but you'll probably see, and I wanted to introduce you to, is this stuff for desoldering. It's called desoldering wick. Essentially, it's braided copper, I think, which you heat up and put on the solder to wick it away. Okay, so it sucks up the solder. Now, as I told you earlier, I'm in love with my fancy Japanese solder sucker, so I don't use this anymore, but you will see this on electronics workbenches, so I did want you to be familiar with it. All right, so without further ado, I am going to show you how to solder some things. How about that? Now, I'm going to set up my little soldering station. I've got my real cute little soldering thing. So basically it's already plugged in. I'm just going to flick it on at the back. And you'll see it's got, let's move that here. You'll see it's got the power on it. Ooh, look at that, it's flashing. It's not real. There we are. So I've got my soldering station. I'm going to pop that at this end. I've got my soldering cleaner, which I told you you've got to keep nice and clean. And I have got my unleaded, free, thinner solder. What else do I need? Maybe some flux. As I say, I'm not the best with unleaded solder, but that is all I've got at the moment. So that's what we're going to have to do. I'm going to show you how to solder on this. So basically, one of the first things that most people solder is a kit. So you can buy these kits. This is actually from a German shop called Conrad. It's called Blinkensherz. And it's a soldering kit. I would highly recommend you can get your hands on a soldering kit from your local like electronics store, or you can support someone such as Adafruit or Evil Mad Scientist Lab, and they've got loads of great soldering kits to help you along on your journey. It's just a really nice way of beginning. So let me just let's open this up. Got some instructions in German, which we don't want because I'm not going to do the whole thing. And then we've got all the parts in it. Okay. What we've got here, this is like an outer shell, and then we've got one of these things. Now, this is something called a PCB, which stands for printed circuit board. And if you look at any kind of electronics, this will be part of it. It's essentially just a something flat that's made out of fiberglass, and it's got a pattern printed on it, and then it's got these lines which are traces. These are electrically connected. Okay, I'm going to show you some cool examples of PCBs in a minute, but this is like a standard one. Often they're this kind of green color. Yeah, but it's the best solder circuit. I know, RIP Radio Shack. So Maplin's was the British equivalent of Radio Shack, and that died as well. All right, so what you'll notice on these PCBs is they'll have different markings. And this is something called a silk screen. Okay, this is just markings that someone's printed on to help you along. And some of them will have little pluses and minuses on them, okay? So that just means that there's a correct way around to put it. Let's take two very common components. These are probably the two most common components, especially in beginners electronics. This is called a resistor, and a resistor helps you control the power in a circuit. It fights the power, quite literally. And it helps you make sure that you don't blow up your LEDs or things like that. Now, a resistor, it doesn't matter which way around you put it, okay? It doesn't matter. It's bi-directional. You can put it any way you want. It doesn't really matter unless you want everything to match. But some things do matter. So, for example, this is an LED. An LED stands for light-emitting diode. It's essentially a tiny light bulb, okay? And they're very, very common. You'll find them in all sorts of things, and you get all sorts of different types of one. This is a very standard LED, but it does have a right way around to put it, unlike the resistor. And the way you can tell is, well, first of all, there's a clue on the PCB. The PCB, it says LED 36. Here we are. LED 36, and it's got a little plus and it's got a little minus, and it's got a flat side and a round side. Now that's a clue that your PCB printed circuit board wants you to put your component, your LED, in it a certain way round. Now, an LED's got some clues on it too. Your little tiny light bulb has a flat side and a rounded side, which will correspond to the flat side and the rounded side, but that can be quite difficult to see, particularly in small LEDs. So there's another clue. If we have a look here, we'll notice that the LEDs, oh, this focus is let's try and get that. It's trying to focus on everything on my bench. So you'll notice that on an LED, you've got two different lengths of legs. One of those is positive and one of those is negative, okay? Now, the way I remember this is that positive is the longer leg, because with positive, so you've got negative here, and for positive, you add an extra bit, okay? So your positive, so your negative is smaller, you add a little extra bit for the for the positive. Look at all my soldering burns. This is disgraceful. I basically have no feeling left in my hands. You should be less clumsy than I am. So essentially what I'm doing is I'm taking, this is my positive leg, the longer one, and the negative leg. And what I'm going to do is I pop them through. So the long leg goes through, let's see if it's at all. That's, there we are. So the long leg, I'm going to pop through the positive hole, and the short leg, I'm going to pop through the negative hole. I'm going to slide it all the way down to the bottom. Okay, look at that. Very nice and neat, precision. All right, then what I'm going to do is I'm going to flip it over, and I'm going to bend the legs just slightly, okay, just slightly, so that they don't fall straight back out when I turn it upside down, okay. We don't want to bend it too much, because otherwise, if you want to desolder it, it's going to be a real pain. So what we're going to do now is we're going to solder our first LED. So it's upside down because I don't want to solder the top bit, which is made of plastic. I want to solder the bottom bit. So here we have an LED, nice and securely popped in there, and we're almost ready to solder. But before we solder, let's take a little look at our soldering iron. So we've got a soldering iron here. I'm holding it by the plastic bit, much like I hold a pencil, okay? And don't hold it by the hot bit, because that way lies very sad pain. So you want to hold it here nice and firmly, like you hold a pencil. And what we're going to do is, you can't really necessarily see, but I've planted both of my elbows on the table. Okay, so instead of just hovering, let's see if I can get this here. So instead of what I'm doing is instead of just hovering and putting this down, what I'm doing is I'm planting my elbows and I'm angling it down, which gives me much greater control. And the same with my other elbow as well. So basically I'm anchoring myself and pivoting instead of just like coming in. So that gives me much greater control. I will also, you'll notice, often stabilize my hand and the PCB while I'm doing it with my little finger. So the more stability you have when soldering, the better, okay? So we're almost ready. We've got our hands anchored, we've got our warm soldering iron, everything's very exciting. So what we need to do before we actually start soldering, though, is take a look at the most important bit of a soldering iron, which is this. Don't get too close, Helen, don't burn yourself on the live stream. This is the tip, okay? And this tip looks a little bit sad. It looks a bit dull and grey. You're seeing. Finished tinning my soldering iron. That was a frustrating 10 minutes there. Apologies to everybody who just dropped off of my stream. They just started downloading a lot of things. Okay, so as you can see, I've got a nice, let's see if I can get it to focus, ish. But you can see, again, there's a nice shiny silver tip here, which is what we want in order to get a nice electrical connection. So what we're going to do is this is very wonky solder. So for another second, and then go out. All right, excuse me, I'm not used to unleaded solder at this point, so we've got a nice clean solder joint here. I'm just going to take it off the stand just to show you. What we've got here is, you shouldn't have too much solder, but it should have like a little main solder that's not blobby. So it's like slightly curved. I don't know if you can see that. Let's move this a little bit. So yeah, you should have not a blobby bit of solder, and it should be nice and smooth, because we don't want it to be either too much or too little. There's a really wonderful visual guide to this, like a little zine by Mitch Altman called "Soldering is Easy," which I would very much recommend you take a look at. It's got great illustrations of all the do's and do nots of soldering. But essentially, the most important thing is, in between each solder joint, I give it a little bit of a clean, make sure it's nice and shiny still. Now I'm holding 1, 2, 3. Make sure it's nice and warm before I apply the solder. onto the joint, not, sorry, the joint should be nice and warm. It shouldn't be like that you're just blobbing the solder on there, okay? You always put a little bit more than you think, then hold it there for a second after you're done. Okay, you see all the smoke coming off. This is the flux melting off, okay? So here we have like a nicely soldered LED. So what we're doing here is, I'm going to show you how to flip it off. We have an LED that's soldered nicely on. It's firmly connected, electrically connected. There's not too much solder. There's not too little solder. Again, have a little look at the Soldering is Easy zine or the Adafruit Learn Guide to Soldering to see an actual nicely zoomed in pictorial representation of what it should look like. And then what we're going to do is, because we don't want these leads here, we don't want these legs, these have served their purpose. What we're going to do is use our snippers to snip them off. Now remember when I said earlier that once you snip it off, if I just were to snip it off like this, maybe into somebody's eyes. So what you should always do is hold the end that you're snipping off while you snip it. So you're not going to go everybody and get in someone's eyes, okay? Snip. That's snipped flush down to the end. So we're not going to get a dirty a messy PCB, okay? So again, here we're going to tidy up this other leg. I am going to support the PCB in one hand and hold the leg, the LED in the other. Snip it again. And we've got an LED that's been soldered on fully, and then the legs off. I'm going to do that a few more times just so you can have a look. Again, so here we go. Again, we've got another, turn it back over so we can actually see which way around we're doing these things. We've got a whole bunch more LEDs. Again, long leg positive, short leg negative. I'm actually going to slot in a bunch of them this time so that we can work on a few of them at the same time. So there's an LED in one of them. Let's pop a few of them in. We're just going to sit here and solder them together so you can just watch me. There's actually a little where you can watch people soldering. This is a very easy soldering kit. Well, I shouldn't say easy because, of course, it's challenge. Anything like this is challenging the first few times that you do it. But when you get a little bit more experienced, you might want to try something like this. This is a more complicated soldering kit. So I hand soldered all of these. These are different chips, and these are something called SMDs, so surface mount components, as opposed to these, which are through-hole components, because you put the legs through the hole. And these use different techniques, which I'll show you in a minute. I'm just going to solder LEDs in so that you can just watch me soldering a few LEDs to get the hang of it. Let's turn it over. Remember, I just I put the legs out a little tiny bit to give us a bit more space. So hopefully we can actually focus on this. Okay. So what I'm also going to do is I'm going to pop a little bit of flux on this. Not because I necessarily need to, but just to demonstrate it. So I just shook up my flux, pushed it down to make the flux flow, and all I'm doing is I'm just painting a little bit of that flux on there. It's a clear liquid, this stuff, so you're not necessarily going to notice it. I'm just going to focus on this again. Okay, so again, I'm levering my arms in to get much nicer angle. I'm warming up the pad and the opponent leg before I add the solder, because we don't want to get what we'd call a cold solder, blob the solder on there. And then I always leave the soldering iron on the component just for an extra second afterwards to let the solder flow through nicely. And that's something that Mitch Altman told me, actually, and he's like the Gandalf of electronics, so we should know. I am not the world's biggest fan of unleaded solder, but it is much safer for you. And notice, so when is it unsafe to touch with bare hands? It's static discharge. So static discharge isn't something you should worry about with more delicate components. So for example, here we have, this is a little microcontroller it's inside this silvery package, which is static discharge proof. You shouldn't go around just like rubbing your fingers on chips and so on. But you know, like, I mean, you don't have to be wearing like anti-static shoes if you're just soldering some LEDs onto a PCB. You don't have to worry about that too much. If you're dealing with something a bit more sensitive, like a sensitive component or a chip or something, you might want to, but you're still going to be fine. I mean, I've hand soldered chips plenty. It's just you don't want to be doing too much handling of sensitive components. You notice that I am cleaning the tip of my soldering iron, usually every time, sometimes every other time. So that's the thing that's going to keep my soldering iron happy, is nice and clean. And I'm not heating with my soldering iron. I'm heating up the pad and the component legs, okay? Because we don't want hot solder going on cold pads, because that way lies the sadness. Okay, let's review it away a little bit. There's definitely a kind of meditative quality to doing a good soldering kit. It's quite fun. I enjoy it anyway. It's kind of a bit like sewing and knitting. Repetitive and enjoyable. All right, so that is, I've got 5 soldered on here. It's all very exciting. Hooray, hooray. Now what I'm going to do again is I'm going to show you that I'm going to clip off some of these legs, but then what I'm going to do is, on purpose, I made this LED a little bit skew-if, so I'm going to desolder it, okay? And we can have a look at how to desolder that in a minute. So which one is that one? It's the penultimate one. So I'm just going to clip off all the rest of them. Remember, I'm going to hold the legs so that it doesn't ping off into my eyes. We don't want that. We don't want to blind ourselves, do we? Then soldering would be much more difficult. Okay. So I have snipped off all the legs, apart from this one, which is a little bit skew-if, but that's okay. I'm going to show you how to desolder it. So that's a useful skill as well, unless you never make mistakes. Now, where's my lovely desoldering solder sucker? Here it is. Okay, so the way that a desoldering sucker works is, I'm not going to heat it up right now, but essentially what you do is, actually I'll just easier for me. Essentially what you do is, when the solder is molten, so when it's hot, what you're going to do is you're going to attach your solder sucker, the silicone bit, to where the solder is, and then you're going to press this button, and it springs back outwards, and it's eats the lovely soldering iron right back. It eats that solder, it sucks it away. So first of all, I am going to pop this here, using my left hand here, and then what I'm going to do is, when I see it start to flow again, you can actually feel it a bit as well. You can suck it away. Look at that. It takes a little bit of practice. But you can't really see because it's not high res enough. Well, it is high res, it just doesn't focus. but it's been sucked clean away. So basically, I'm going to do that again on this side. I'm going to heat up this the solder around it. Yeah, and then I'm going to suck it away. Now, let's see if that's able to come out. On one side it's free, but on the other side it hasn't. It's left a little bit of solder, enough solder there. It's left enough solder there to stick it to them. So what you do, and it sounds a little bit counterintuitive, but sometimes the best way to desolder something is to put more solder on it, because then you get enough solder to suck it away again. So I'm going to bang a bit more solder on it. If it plays with me. Yeah. So there's a bunch more solder on that solder station. And what I'm going to do is, again, I'm going to heat it up. And then I'm going to in the end of my solder sucker, which is stopping it from sucking it up properly. So what I'm going to do, do it again. Lovely solder stick, lovely solder sucker. Oops, nothing wasn't on the correct bit. Is it still going? Good. Okay. We have a lovely desoldered component. Okay, so that is how to solder and desolder a part. The desoldering takes a little bit of fiddling around sometimes, but it gets easier as you get a little bit more practice. So that's how to do ordinary through-hole soldering. I'm going to show you very quickly. Taught me that. I kind of guessed it. And then looked up on YouTube Studio. So once you start looking at more complicated soldering kits or doing your own thing, you might want to use different parts. So SMD. So this is what a PCB looks like, by the way. And this is these little pads here. They're called little pads. You'll see that some of them will have like a hole. That's what a through hole is, and some of them will just have pads, right? And sometimes your SMD soldering will come with these pads instead of these are examples of the pads as well. Instead of actual through hole components. And what you need to do then is a little technique. It's not so difficult once you know how to do it, but I'll show you. Instead of soldering the component on, what you want to do is create a little pillow, essentially, a little pillow of something, and then place it on with, so basically here we are. Instead of putting it in the helping hands, what I'm doing is holding it just down to the table here, but you can use your helping hands if you want. And what you're going to do here is use your soldering iron to melt a little pillow. There we go. See if you can see that. Here we are. Yeah, you can see that's that. I've melted a little pillow of solder onto one end of the soldering station. What you do next is you take your SMD tweezers, and you take your strip of SMD components, and you can peel them off like so. It's a little bit fiddly. They're very small as well, so So what you do then is you can see here, look how tiny they are. These little things. Again, this is advanced stuff. I just wanted to show you what it looks like. So this is what an SMD component looks like here. You see that? So the autofillers, here we are, there we are. So an SMD component looks like that. And what you do is you place it, this is actually the wrong size, but you can still get what I mean. You place your SMD component, the one side on the little pillow of solder, and then once it's placed, you hold it in place with the tweezers, and then you melt one side. And then you'd solder the other side, just like you'd solder normally in a through-hole thing. So yeah, I mean, I'm not gonna do much SMD soldering, but I just wanted to show you what it looks like and tell you the theory of what it does, so that if you ever see this on a kit, that you're not going to get confused. You're just like, oh, okay, that's a part that goes on top rather than through the hole. And then all you do is you do a little pillow on the thread one side. So yeah. The last thing I wanted to show you is how to solder a header. So, well, I'll show you that you can do these. So often you'll get this is like a small microcontroller, a little tiny computer, and you'll see that there's a bunch of different headers. So this is what's known as a header, and they leave them not soldered on because sometimes people want to use these with the bare wires. They might want to use them with a breadboard, but here you solder them on yourself. Okay, so these headers are sometimes too long. If they are too long, you use your faithful snippers to snip off one or more of your headers. And then what you do is you put them in place and you solder them one by one. And the easiest way to do this, and I wish somebody had told me this when I was first starting out, is you pop them into a breadboard, which is a prototyping tool. Now we're not using this breadboard for anything actually real. What you're just using it to do is keep the headers in while we solder it. Okay, so again, hold it down. Remember, you're heating both the pad and the component, in this case the header, and then we're feeding in the solder. So yeah, there we go. Now, that is how to solder a header. I didn't actually solder it on because I actually didn't want this one soldered on. But yeah, basically you just do them one by one. Now these are complicated to desolder. They can take a long time. So my recommendation for this is if I do need to desolder a header off of something, I will often use my little snippers to snip 1, 2, 3, and so on. You snip all the way down the row, and then you can desolder them one at a time. And in fact, one of my friends gave me that tip. It's a killer tip. Is if you can't get a header out when you push it through, use a jumper cable to kind of physically push it through while the solder is warm, so that you get a nice clean, and then you can just pull the jumper cable out. So you can use the end of a jumper cable to desolder that. Okay, so that is a basic introduction to soldering. The final thing I wanted to make you aware of, so we went through all my electronic tools. We went through how to solder through hole and SMD and jumpers. We did some desoldering even. And we showed you the SMD things. The final thing I wanted to talk to you about is this is something that these two things, you'll see these on your electronics workbench as well. This is called a breadboard, and this is called a protoboard. So a protoboard and a breadboard are prototyping tools. And you'll get them in two form factors. This is called a half, and this is called a full. These are the two most common. You can also get them different colors. So here is a black one. They do vary quite wildly in quality. I would definitely, to save you pain and heartache, recommend that you buy your breadboards from somewhere good. This breadboard I bought because this black breadboard I bought off of eBay because I thought it looked cool, but it's been an absolute pain. It breaks quite frequently, and it's really difficult to get pins in and out of. So I'd always recommend buying something a little bit, it's only a couple of dollars more expensive to buy one from Adafruit, but they're just much better quality. They last a lot longer, and you don't have things breaking all the time. Anyway, so a breadboard is essentially a prototyping board. It means that you don't solder. It's just meant for, here's something I'm prototyping at the moment. It's meant for like popping in, and it's meant for popping in components before you're sure of your design. Okay, so once you're sure of your design, you might want to use a prototype, a printed circuit board, or you might want to use something like this as a permanent proto board. But before you get to this, you'd solder things onto this, and then it would stay there. So soldering is pretty, not final, but it's when you're sure of your design. But before you get to the prototyping, the PCB stage, you may wish to use a breadboard. Like this. You just put the components in and out. Let me grab myself an LED. So here we have, so you can, little holes that work in two different ways. They've got two columns and then a whole bunch of different rows, okay? Which are divided into two sections. Now, if I turned this over and I pulled off the back of this breadboard, you'd see that each of the rows in this column and this column are electrically connected by just a strip of metal, okay? And this also would be electrically connected with just a strip of metal. It's just a long column, okay? So this has got plus or a negative, but that's just to help it be a little bit more user-friendly. It's just strips of metal, long, thin ones on here, and then like shorter, thin ones going across, so columns and rows. And if you Google image search for the underneath of the breadboard, you'll see what I mean. And what you do is you use those holes to put in your components. So, for example, I want my negative leg of my LED to go here and my positive leg of my LED to go in there. I can then use a jumper cable to connect the so this is the positive leg here. I can connect that to the positive rail over here. This would then get connected to a battery or a resistor or whatever. It's just a way of making a circuit without it being permanent. So obviously, like, you can just pull these out, or if I wanted to add in a button, or if I decide, oh, I need to add in a resistor, I can just like plop it in there. It's really not so difficult. So here we are. That's a resistor that's gone in. I don't know what value that is, but it's, if I connected this up to ground and this up to power, this LED would now light up. I'm assuming, well, I think this resistor is a wrong value, but I'm assuming this resistor is the right value. But if I wanted to add in something else, so for example, like a button, I could do that here. So it essentially allows you to chop and change, experimenting with your resistor, with your different components, while you're finalizing the design of your circuit. Breadboards can be a little bit confusing at first. I would just recommend you have a little look at what they look like when they're stripped away, because there's like lots of numbers and letters. They don't necessarily mean anything unless you want them to, again. So you can have your things go anyway. It's just that there are electrical connections. So as long as you remember that these ones are electrically connected down and these are electrically connected across, but not bridging the gap, then you're going to be golden. Okay, well, I have been going for nearly an hour and a half, and I'm supposed to go only for an hour. I mean, I know there's been technical difficulties in that time, but hopefully I've given you a little bit of an insight into the basic electronic workbench and the basics of how to start yourself soldering and how to start yourself working with some of the tools that you will see on your electronics workbench. So thank you very much for hanging out with me, and hopefully I'll do another one when I'm slightly more when my connection is a bit more stable. But yes, okay. Thanks everyone. I'll see you soon.